My dear students, in this video I am going to start a new topic in the 12th standard state board syllabus, namely the chapter 3, theory of equations. This theory of equations is an important topic to solve the various types of equations and to find the solutions of these equations, and are very useful in our topic algebra. So, further consider the polynomial p of x equal to an into x power n plus an minus 1 x power n minus 1 plus an minus 2 into x power n minus 2 etc. a2 x square plus a1x plus a0, which is a polynomial of degree n, and a1, an minus 1, an minus 2 etc. a2, a1, a0 are the coefficients of the polynomial and are also constants. Coefficients of the polynomials are also constants. And x is the variable. This variable x is real or complex number. Its variable is real or complex. If all the coefficients are real, then p is a polynomial over r. If all the coefficients are real, then p of x is a polynomial over r. If all the coefficients are complex numbers, then p is a polynomial over c, and so on. Now, the term an into x power n, is called the leading term of the polynomial, and also the term an, the coefficient an, is called the leading coefficient. So, the leading term is having the highest degree of the polynomial. That degree denotes the degree of the polynomial. So, we say that the degree of the polynomial is n, the leading term consisting of degree n. It's a non-negative integer. Therefore, the degree of the polynomial is n, and an is the leading coefficient, and an x power n is the leading term of the polynomial. Okay? Now, we will consider the various types of polynomials. See, if the degree of the polynomial is 1, then it is called a linear polynomial, that is example ax plus b. So, degree of the variable x is 1, ax plus b is a polynomial of degree 1, and this is called a linear polynomial or linear equation. Similarly, if the degree of the polynomial is 2, then it is called a quadratic polynomial. If the degree of the polynomial is 2, it is called quadratic polynomial, example ax square plus bx plus c. Similarly, if the degree of the polynomial is 3, then it is called a cubic polynomial. It is ax cube plus bx square plus cx plus d is an example for cubic polynomial. And the degree of the polynomial is 4, then it is called a quartic polynomial. Quartic polynomial. Example ax power 4 plus bx cube plus cx square plus dx plus e. Now, if you consider that it is an equation, polynomial equation, that means ax square plus bx plus e equal to 0. If you write this equation, similarly ax cube plus bx square plus cx plus d equal to 0, if you write, then it is called a polynomial equation, cubic polynomial equation or cubic equation. Here I am writing ax square plus bx plus c equal to 0. It's a quadratic polynomial equation or quadratic equation. Since the degree of the polynomial variable is 2, it has two values for x. Those two values are called roots of the equation or zeros of the equation. If the value of the degree of the polynomial is 3, we have 3 values of x. Those 3 values are called roots of the polynomial equation of degree 3. And also the roots are also called zeros of the equation. Okay? Now, we will consider a quadratic equation, general quadratic equation. We know that the general quadratic equation is ax square plus bx plus c equal to 0. And you know that the roots of the quadratic equation is minus b plus r minus root of b square minus 4ac by 2a. These are the roots of the quadratic equation. One root is minus b plus root of b square minus 4ac by 2a, which is called alpha. And you consider another root minus b minus root of b square minus 4ac by 2a by beta. Because it's a quadratic equation, it has two roots, and the roots are minus b plus r minus root of b square minus 4ac by 2a plus root b square minus 4ac by 2a minus root of b square minus 4ac by 2a is another root. These are the things you have studied already in your previous year course, 7th standard. Sum of the roots is alpha plus beta is minus b by a. Product of the roots alpha into beta is c by a. These are the things you know you have studied. And the discriminant part b square minus 4ac is called delta. B square minus 4ac. This is called the discriminant part of the quadratic equation b square minus 4ac, and it is noted by delta. You know that if delta equal to 0, you know that the roots are real and equal. If the discriminant part b square minus 4ac equal to 0, that is delta equal to 0, then the roots are real and equal. And if delta is positive, greater than 0, then the roots are real and unequal. Then the roots are real and not equal. Real and different, I mean. And third one, if delta is negative, then the quadratic equation has imaginary roots. Then the roots are imaginary. These things you have studied already. Okay? Now, we are going to form a polynomial equation by using the sum of the roots and product of the roots. And that formula is called the Vieta's formula. Vieta's formula for formation of polynomial equation. Suppose it's a quadratic equation, if alpha and beta are the roots of the quadratic equation. So Vieta's formula for formation of polynomial equation is x square minus sum of the roots in the x plus product of the roots. Equal to 0. So x square minus sum of the roots in the x plus product of the roots equal to 0 is a Vieta's formula for formation of a polynomial equation of degree 2. If alpha and beta are the roots of the equation, this is nothing but x square minus sum of the roots is alpha plus beta into x plus product of the roots is alpha beta equal to 0. This is the Vieta's formula for formation of polynomial equation. Now let us consider an equation. X square minus 8x minus 15 plus 15. See, this is x square minus 8x plus 15 equal to 0. You consider a quadratic equation. The roots of this equation is x equal to minus b plus or minus root of b square minus 4ac. C is 15, a is 1, b is minus 8, c is 15. X square minus 8x plus 15 equal to 0 is a quadratic polynomial equation. So roots are minus b plus or minus root of b square minus 4ac. A is 1, c is 2 by 2a. So this is equal to minus or minus plus 8 plus or minus root of 8 square is 64 minus 4 15ths are 60 by 2. So this is 8 plus or minus 64 minus 60 is 4 by 2. That's equal to 8 plus or minus root 4 is 2 by 2. Therefore the two roots are alpha equal to 8 plus 2 by 2. That is equal to 10 by 2, that is 5. Beta equal to 8 minus 2 by 2. That is 8 minus 2, 6 by 2, that is equal to 3. So alpha and beta are the roots. Alpha 5, beta 3. Sum of the roots you know. Alpha plus beta is 5 plus 3. That's equal to 8. Product of the roots alpha beta is 5 into 3. That is equal to 15. So by Vieta's equation, x square minus sum of the roots into x plus product of the roots equal to 0, we get the original equation. X square minus 8x plus 15 equal to 0. See, if it is a given equation x square minus 8x plus 15 equal to 0, the roots of the equations are 8 and 5 and 3. By using this result, we can find alpha equal to 5, beta, the root beta equal to 3. So sum of the roots is alpha plus beta, 5 plus 3, 8. Product of the roots 5 into 3, 15. By Vieta's formula, we can again arrange the equation x square minus sum of the roots 8 into x plus product of the roots is 15. We get the original equation. So like that, we have solved the problems. And I will stop the video here and we will continue in the next video. Thank you.